everyone. So glad that you are here. So, that should be good. Okay, so let's go ahead and take a look at this Unit 1 test review. So the first thing we want to know is whether or not this is a function. So whenever you have any type of graph, you want to do a vertical line test. So I could do a vertical line along any point. And you can kind of just tell from looking at it, right, that it does not hit more than once. Because it hits it only one time for every vertical line, it passes the vertical line test, and so it is a function. So determine whether or not it's continuous or discrete. We need to take a look at our line. Because it is continued, it is connected, I would not need to lift up a pen or a pencil to draw it. That makes it continuous. Okay, so for domain, we are going to look at the x values. So if I take a look, I see the lowest x value right here would be -3. So if I'm going along the lines, I want to keep going to can't go left anymore, which is the lowest x value. This right here is -3. This has an open circle, which means I cannot equal that value. So my domain is the lowest value is -3, and then my x has to be greater than. Okay, the x has to be bigger than -3, and that matches with here that all of these values are an x value larger than -3. So if we kept going, I could get bigger, bigger, and now I'm in the positives, and we want to see where the x value stopped. The x value stopped right here, where x value is 1. So it has to be less than or equal to 1. We know this is less than or equal to because this is a closed circle. So because it is a closed circle, we could have a less than or equal to because I have a value here. You cannot have a value here, but you can have a value here. Anytime it's along a line or a closed dot, you can have a less than or equal to. The only exception is infinity, or if you have a open circle. Now, for the range is the y values. So the lowest y value would be over here, and the highest y value would be over here. So if I take a look over here, it doesn't matter if I choose here or here. They both have the same y value of -4. So my lower bound of y is -4 because it can be a point. It can be less than or equal to. And the highest point is 0. Although there is an open circle here, because this is a line, I have a value of 0, 0 right here. So I can have a y value of 0 because of this line. So this is the only reason why it has the line below, because of this line right here. Okay, so for our discrete functions, you can also use a vertical line test. At each point, there is no value above or below that is on the same vertical line. Therefore, each x value has its own y value. So we would consider this a function. Because the data is disconnected, they are not connected, it's discrete. Domain is the x values. So when we're listing the domain for discrete, we want to list in a list. We do not do the inequalities. We do it in a list, okay? The reason why is partials are true in continuous, partials are not true in discrete. Remember we talked about we don't have half of a puppy. Okay, so the lowest x value would be -4, and then 2, and then 1, and then 3. Lowest y value would be -2, -1, 2, and 3. Continuing on to the table. I know it's a function as long as there are no repeating x values that have a different y value. So there's no repeating x values. That makes this a function. For the most part, anytime you see a table, it's always discrete. Essentially, it's just listing like the points. Instead of being points on a table, points on a graph, you're having points on a table. So this would be considered discrete. You list it the same way as the other discrete one. You're going to write it in a list. So least to greatest, -5, -3, 0, 7. The range, -7, 2, 10, 17. Once again, least to greatest. Now we're going to continue on to our problem for number 4. There we go. All right, so vertical line test. If I draw a vertical line pretty much anywhere throughout that circle, you can see that it actually hits that twice. So you can see that it hits my vertical line here and here. Because it fails the vertical line test, it is not a function. So, not a function. To draw this circle, it must be continued. At no point would I need to lift my pen. So I would consider that continuous. For domain, that is all of my x values. So the lowest x value I have is here, -2. The largest x value is 2. If you have a continuous situation, then you're going to write it as an inequality. So the lowest value is -2. Because there's no open circles as points, it's just the line, then I can have the less than or equal to. Oh, I was getting ahead of myself. I was thinking about y for domain. Okay, I'm sorry, y for range. I was thinking ahead. Okay, so for my range, those are my y values. It's actually the same numbers, -2 to 2 as well. Okay, number 5. So this is a situation showing mapping. So the biggest thing with mapping is we want to see if there are 2 outputs for this input. That basically means this 6 right here is duplicating. So this 6 right here has a value of 5 for the y and also has a value of 10 for the y. I don't care that 2 numbers are going to this 10. All I care about is my input. That means two x values are 6. So because 2 x values are 6, this is not a function. Just like the table, anytime you have like a list of numbers, that's going to be discrete. Okay. The domain for this is actually already the same as the other discrete functions. You're just going to list it. So do your cute brackets, 3, 6, 12, 18. The input here is your domain, your x. The output here is your range, y. So the range is 5, 7, 9, and 10. Okay, so for this one, the domain has to be less than or equal to 0. So my x value has to be equal to this line at some point. My x value has to be less than 6. 1, 2, 3, 4, 5, 6. There's 2 dashed lines. It won't equal that side because it's just less than. So we're going to have some type of open circle there. Okay, and then -4 is the bottom of the range. So that will be a solid line because it will equal the -4. -1, -2, -3, -4. And then it has a top value of 5. 1, 2, 3, 4, 5. Okay, because of these lines and these dashes, I know I need to essentially start here and end here. It could look any which way. The biggest thing is that this has to be some type of dot, closed, not open, and this has to be some type of open dot. If you want to make it simple, you can just draw a line straight across. Ignore the music, that is the school bell. Okay, continuing forward. Hopefully you get a little nice background music. Okay, so a Walnut Grove High School is having a pancake breakfast fundraiser. They are selling pancakes 50 cents a pancake. The student council only bought enough pancakes to mix 500 pancakes. Identify the range given that the domain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so is this discrete or continuous? This is discrete. There are no partial pancakes. Oh, I don't know how to spell pancakes. Okay. If each pancake costs 50 cents, then one pancake is 50 cents. If you have two pancakes that cost 50 cents each, that costs $1. So I'm just going to continue the pattern. And then we end up off at 5 for the 10 pancakes. So 10 pancakes cost $5. Okay. This is our function notation. So this function name is h, this function name is j. It actually has no meaning behind it. All that it's doing is letting us know it's called that. So inside the parentheses is this value. So my x value is -3. So what I can do is input my x, this is h, so it's going to go to function h. I'm going to input x value of -3 right here. So -2 parentheses -3 squared plus 7. Think of PEMDAS, exponent first. -2 times 9 plus 7. That's going to give you -18 plus 7. And then that's going to give you -11. You could skip steps and just put this directly in the calculator as well. For this one, you have 2 over 5. So you put it in function j. So you have 5 times 2 over 5 minus 3. 5 times 2 over 5 gives you a value of 2. 2 minus 3 gives you a value of -1. Okay? Same process here. Put the 5 value in here because we're dealing with function j. The x value is 5. 5 times 5 minus 3 is 25 minus 3, which gives you 22. Oh, sorry guys, this bled over. Okay, so these are your function notations. All right, range of g of x. So my x values are -2, 0, and 3. Okay, so what it means to find the range values means I need to find all of the y values for these x's, which is my g of x's. So I'm going to input all of them. So I'm going to have to find g of -2, g of 0, and g of 3. Okay, so now I'm going to input all these values. So 4 times -2 squared minus 5. I'm going to do the same with all the x values. I just plug in this x into this equation here. So 4 times 0 squared minus 5, 4 times 3 squared minus 5. Once again, if you hit to this point, you could put this in a calculator, let the calculator solve the rest. Good habit to always make sure we understand how to get there though. So -2 squared is 4. 4 times 4 is 16. And then 16 minus 5 is 11. 4 times 0 squared, that's just 0 times 4 is 0. Minus 5 is -5. 3 squared is 9. 4 times 9 is 36. And it gives us 31. Okay, you want to order the range least to greatest just like we did up here. So -5, 11, and 31. Okay. Okay, given that f of x is x minus 2 and f of x equals 4, what is the value of x? Okay, so that means that this f of x is 4. So I replace this f of x right here with 4. We're not this is giving us our x value. This essentially is giving us our y value. So 4 equals x minus 2. To get rid of that minus 2, you add a 2 on both sides. So you get 6 is equal to x. And you could write it down here too. Okay. All right. So when we're looking for these are in a table. Compared to these, we had to calculate, right? The values are in the table. So when you see this, it's actually pretty easy. So let me color code this a little bit. Okay. So f of 1, this means your x is 1. Okay. Hold on one second. Let me see if I could pause this. Okay. Let me make sure I go back. Okay. All right. So this x value right here is 1. So that means I just need to go over here and find when x is 1, my y value is -1. Now, this one is different. See how the 1 is inside the parentheses? This one over here is f of x equals 1. That essentially means that y equals 1. So I'm going to go to my f of x, which is the same as my y column, and I find the 1 here. So I'm going to take a look. So this means that y equals 1. So I'm going to go to y equals 1. And then from here, I'm going to see that the x value, because right, it's looking for x equals, the x value is 3. Okay. Right here, this is asking for f of 4. So that means x equals 4. So I'm going to look at when x is 4 and find my y value, which is 2. So your answer here is 2. Okay, so now it's looking at when f of x is 0. I need a different color. Okay, so that means that your y is equal to 0. So I'm going to go to y is 0. And then I see my x value. It's asking for the x value is 2. So you can kind of see the color coded. This gives you x is 1, gives you y is 1, gives you x is 4, gives you y is 0. And then you find the corresponding ones in the table. Number 14, create a distinct graph that does not represent a function, okay? So if something does not represent a function, that means that there has to be duplicating x's. So that means you have 2 x's on top of each other. Now this one, a vertical on top of each other. So this could be any type of graph. You can create your own. You can put points wherever. The biggest thing is that it needs to fail the vertical line test. So as long as it fails the vertical line test, you know that it is not a function. Okay, so the biggest thing for situations for continuous and discrete is we want to determine if you can have partials or decimals, or discrete is whole. Okay, so if you can have decimals, it's continuous, discrete is whole. So how many pets? I cannot have a decimal. I can't have 1.3 pets. So that would be discrete. Time it takes to fill up your car and gas. I could have partial for hours, minutes, seconds, and I can also have partial for gallons of gas. So because there's decimals involved, this is continuous. How many chairs are in a room? We don't count halves of chairs or 3/4 of a chair, so this would be discrete. Time it takes ice to melt. Time is continuous. You have partials. And then ice melting, you'd have part of the ice melting. It's not like ice is instantly water to ice. So that'd be continuous. Okay. So this one right here is very similar to this one right here, but instead of looking in a table, we're going to be looking at the graph. So if I'm looking at f of 5, that means my x is equal to 5. So if I go to my x-axis, I go to 5 and I go up, I see my y value is 4. Okay, the next one is asking about f of -2. So what that means is my x value is -2. So when my x value is -2, then I'm going to go up here and then find that my y value is 2. So this one's a little bit different. This one says when f of x equals 4. So that means my y is equal to 4. So what I need to do is go to when y is 4, and I'll just do a line across this way. The thing about this one is there's multiple values. So there's one at 2, 3, 4, and 5. So there's multiple values. What is x when f of x is 0? So that means that my y value is 0. So y is equal to 0. So if I look when y is 0, that's over here. And there's only one point when y is 0, and that's right there. Okay? So what that means is the y value is 0, and also the x value is 0. Okay, so taking a look at those, you can see it's similar, but instead of looking at a table, you have to distinguish it in the graph. Okay, last question. A small swimming pool holds 50 gallons. It begins draining at a rate of 5 gallons per minute. Write down the domain and range for the situation and explain what each represents in the context. Okay, so domain, that's going to be our time. Whenever you have time in water, time is your domain. Okay, so the time, we can see it doesn't specify. It says 5 gallons per minute and 50 gallons of water. So you'd have to do a little bit of calculating. That 50 gallons divided by 5 gallons per minute equals out to a max of 10 minutes. Okay, so the lowest value I can have is 0, right? Because we can have 0 minutes pass. The max for it to be filled would be 10. So we're talking about gallons and time, which can have decimals. So that's going to be continuous. You're going to write this as a continuous domain. So the lowest value is 0. And the biggest value you can have is 10. Okay. And then says explain what it represents in the context of the pool problem. So the least amount of minutes to fill the pool is 0, right? Probably won't be 0, but physically possible would be 0. We can't have negative minutes. And then, so the least amount of minutes to fill the pool is 0. And to fill the pool has a maximum time of 10 minutes. Okay, so now we're going to be taking a look at the range. So domain is the minutes. Oops, sorry, it fell down. I need to hold it back up when I grab my next writing utensil. This one will do fine. Okay. Pull this in half, sorry. That's better. Okay. So my range is going to be the gallons. So the pool, the least amount it could hold is 0. The most amount it could hold is 50 gallons. Okay, so in the context of the swimming pool problem, the least amount of gallons in the pool, it's harder to write when I folded it. Sorry, guys. So least amount is 0. The most amount of gallons in the pool is 50. Hopefully this helped you, and continue to study and make sure you look at all the resources in the Google Classroom.